back, we're going to look at this problem. This is number 10 from section 4.4. We have in example 2, it says they come up with this formula. Well, let's just come up with that formula right now. So we have this rectangle inscribed within a circle whose diameter is 8. Okay. And what we want to do is we want to, let's see how we find that perimeter function. Okay, the perimeter of the rectangle. Okay, so the perimeter of any rectangle, of course, is 2 lengths plus 2 widths. Now, of course, in this reference, we might be beneficial to just call them x and y. So we'll designate this is x and this is y. So, of course, then that takes us down to the perimeter equals 2x plus 2y, which really isn't any different, but where does the diagonal come in? Well, of course, the diagonal splits the rectangle in 2 right triangles, upon which Pythagoras is going to hold here. Okay, so by Pythagorean theorem, we would have that x squared plus y squared equals the hypotenuse squared, which is 64. So if we want the perimeter as a function of x, then we're going to have to resolve this expression for the perimeter down here, such that we can replace y in terms of x, and here comes our connection right there. So on that front, then we have that y is going to equal the square root of 64 minus x squared. And replacing that now, we can now express p as a function of x, which would be 2x plus 2y, but y is, of course, down around equals 64 minus x squared. And, of course, there's our function that's called for up here. And, you know, that would be the perimeter function, and all they're asking for is what's p of 1. So plug 1 in and find y, plug 2 in, so on and so forth. Okay, you could do that quite easily on your calculator with a table, and that's what I would suggest, because we should be able to come back and optimize this problem with our calculator by finding the function and probably optimizing it by probably finding the dimensions of x, which will give us the greatest area. So maybe that's something we'll come back and do later as an optimization completely with our calculator. Obviously, we see that this is a non-quadratic, and that's fine. We just still optimize it. Okay, so there you have it.